questions from Concepts of Physics by Hcverma, Volume 1, Chapter 3, Rest and Motion Kinematics, and we are doing questions for short answer. Here is question number 11, which is we have to refer to this particular figure given below. Figure shows the x coordinate of a particle as a function of time. Find the sign of Vx and Ax at time given at these points of time. T is equal to T1, T is equal to T2, and T is equal to T3. First of all, if you have gone through this chapter, then you will know that this is a position time graph. This is a position time graph. And the question being asked is only the signs of velocity and acceleration at these are the instantaneous velocity and instantaneous acceleration at these particular points. So the best way to do this is make the velocity time graph. Looking at the graph, I am able to identify that. Looking at the graph, I am able to identify that this slope is increasing. That is, there is an increasing slope. That increasing slope, I am assuming it to be uniform, and therefore I will make a velocity time graph in which I will show a uniform increase in velocity from the time t equal to 0 to the peak position. So making the velocity time graph, I have the graph like this. We will make it just below this graph so that we are very clear, we are in sync with the present position time graph. Let us say we make the graph like this. Our T1, T2 and T3, we can also draw like that. This is the time corresponding to T1. This is the time corresponding to T2. And this is the time corresponding to T3. So we can mark here our times. T1, T2, T3. Remember, I am making velocity time graph. So what I will do is that I will assume that the velocity has varied uniformly from time t equal to 0. T2 is not the peak. How can you guess T2 is not the peak? Carefully see here. This is not the peak. So what I will do is that I will show the graph. In fact, I can use red color for that. So just before T2, I am making that velocity increases there, and after that I am making the graph like this, velocity decrease, and finally it is becoming 0 at somewhere here, flat. So this is the velocity time graph, and at T1 we can see that at this point that the velocity is, the slope is increasing. The slope is increasing. Therefore, at T1 the velocity is positive. And what is the slope of this one? Acceleration. That acceleration is also positive. At T2, the slope has become like this. Therefore, the velocity is negative. And acceleration is the velocity is the slope of the velocity time graph. That is also going out to be negative. And similarly, at T3, velocity is going out to be negative, and acceleration is also going out to be negative. Because only velocity signs have been asked, we are able to identify from this. I hope the idea is clear, students.